Okay, this is going to be the Algebra 2 review video for 2015-2016. I'm going to skip the first page of properties. You'll get this in class. I'm going to go on to the next page. Alright, so on this one, what you have to do is match the following numbers to the number system that most specifically describes each number. One of the things that I think will help as you go is you have what they call natural numbers, whole numbers, integers, rational, irrational, okay, real, complex, that's irrational, and imaginary. Okay, so the way this goes is this works down the list like this. That's integer. Okay, real. So natural numbers are like our counting numbers. Whole numbers are like the natural numbers but zero. Integers are non-decimal numbers including zero with negatives in there, all kinds of stuff like that. Rational are fractions. Irrational, no fractions. Okay. Real, and then imaginary obviously is I, or pure imaginary, some might call it. So what you should do is you look at negative square root of 5. Alright? So as I type in the square root of negative 5, alright, I try to make that a fraction, I can't. So that's going to be an irrational. Alright, so that's going to be C. Okay? The next one, negative 4. Okay? The highest one that it is it's going to be an integer. Okay? So that's going to be B. Alright? 0. The highest one that 0 is whole. Okay? So I'm going to find whole. 1/4 is a fraction. Okay? So the highest thing that's going to be is a rational number. Okay? We'll come back to A plus BI in a second. Square root of 9 would be 3. The highest thing that could be there is a natural number. Okay? D. Alright, square root of negative 7. Now, to trigger calculator in imaginary mode, which is key, go to Shift, Menu, and go down to A plus BI. Make sure that's turned on there. Okay? Alright, so if I do this, negative 7, you see that I have an I there. So that's going to be the pure imaginary. Okay? This right here is considered a complex number because it's got a real part and an imaginary part. So what's the letter I haven't used yet? Use A, B, C, D, E, F, G. This will be a real number. Okay? Because there could be all kinds of different combinations there. Now, this picture will help you over here. Okay? So what I have here is this is complex. Okay? If you're working backwards, this is the pure imaginary. Okay? Alright, because it stands by itself. Imaginary. Okay? Now, this is going to be real numbers and irrational numbers. Okay? The irrational numbers are going to go there. Then we got rational. Okay? Alright. Integer. Whole. And natural numbers. Okay? So use this chart, you work back up, okay? And that's how you use that chart to help you fill that in. Alright? So just take a look at that. That's how you would fill in that chart. Alright? Then the next problem says, okay, alright, when you multiply this kind, alright? So I'm going to go ahead and do that. I'm going to do 2 plus 3i. Shift 0 gets you the I, by the way. Shift 0 gets you I. 5 minus Shift 0I. Now, that is a complex number. Okay? So it's not a pure imaginary. When you multiply, what type of number is the result? Okay? So you look at what's the lowest rung on there. It's got to be complex. Okay? Alright? Now, let's go to the next one. When you multiply 4 minus I, and 4 plus I. Okay, now 17. Now here's what you have to do. Let's go back up here for a second. Okay. If you look at 17, 17 is a natural whole integer, rational, real, complex. Okay? So it's all of those. Okay? The only thing it isn't is pure imaginary. Okay? So technically, what I want to circle is I want to circle, it's not an irrational number. It's a natural, not a pure imaginary, but it's rational, real, and whole. Okay? So make sure you pick as many of those that apply to that. So let's go on to the next page. Okay, let's start reducing some radicals. Okay? What you have to do here, okay? Now, very important, all right? When you deal with negative cube roots, you got to go back to your menu and turn this back to real if you're working in a Casio. So real would be under F1, okay? You hit F1, it'll turn back to real. I always want to type in my result, okay, at the very beginning because I want to make sure that it's not a perfect of anything. And as you can see, it's not, okay? Now, what I would do here is I'm going to divide negative 162 by 3, okay? It's negative 54. Now, as you can see, my answer is negative. So when I get done, I'm going to deal with the negative. For right now, I'm going to write the answer out as positive 54. This is a 1 for x. I subtract those, so that's x8. Okay? Now I'm going to break this down. 2 and 27, 3 and 9, 3 and 3. Since it's a cube root, I'm looking for a triple. So that's going to be on the outside. I'm going to have 3. Okay? All right? My cube root there. That's my leftover, so that goes inside. For x to the 8th, okay, I take 8 and divide by 3. Now, if you notice in the calculator, if you divide 8 by 3, I get 2.6, which means I got 2 with the remainder. Here's how I figure out the remainder. Multiply back, I got 6. How many more to get to 7? 2. So this is going to be x squared and x squared. Okay? Now, since my answer is negative, I got to make sure I got a negative out front. Okay? If you want to check to make sure you're right, negative 3 square root 2. All right? Okay? Oops, not negative 3 square root 2. Negative 3 cube root 2. Okay? And that matched my original answer. Okay? So I know I'm correct. If this number's prime and it matches your original, you're right. Okay? Let's move on to this. Now, how you type the fourth root in, you type 4, and then right here, if you go shift in that, okay, 192, all right, that will show you, all right, what that is, 3.72. So I should end up with that when I get done. All right, so 2, I believe this would be 96, 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. I can cross off everything with double branches. Now, since I'm looking for groups of 4, I'm going to circle all those. Okay? Now, so 2 would stay on the outside. Fourth root of all of these are going to go on the inside. 2, 2, and 3, which would give me 12. Now, let's check my number. Okay? Let's see if that's right. So how I would do that is 2 times fourth root of 12. All right? As you can see, that's the right answer. Now, 12 is not prime, but there's no combination here that could get any smaller. All right? Now, so what I'm going to do is I'm going to take 2 and divide it by 4. Now, what happens there when I do 2 divided by 4, you'll notice I don't get a number in it. So what that means is all of that is going to stay on the inside as x squared. All right, y to the fourth. 4 divided by 4 is going to be 1. So that's just going to be y to the first on the outside. Then I got z7 divided by 4. Okay? 7 divided by 4, all right, is 1.5. So I got 1, and I know I have the remainder. So I work back. 1 times 4 is 4. How many more to get to there? 3. So I got z1 on the outside. Okay? Put that z1 on the outside, z cubed on the inside. So this would be my final answer. Okay? Moving down to number 21. Move that up over here. All right, so I can see it. Okay? All right. So I got the 6th root. All right. Now, once again, I'm going to type in 6. All right, shift 64. All right. Wow, I got 2. That's fortunate. I don't have to break that down. I know that my answer outside is 2. I'm still going to take these. 6, I'm going to divide by 6 because I'm always going to divide the exponent by the root. Okay, I don't know if I made that clear. I divide by 4 here because that's the 4th root. All right, so that's going to be 1. So outside I'd have 1. All right, y to the 13th. Okay, divided by 6 would be 2. Remainder, that would be 12. That would be 1. All right, so I got y squared. All right, on the inside I would have y. All right, okay, z. 3 divided by 6. Once again, if you look at that, 3 divided by 6 is going to produce that. So that means z of 3 is going to stay all inside. So what I got is, I got that. So that's going to be x1, y2. Okay? That one, this is pretty messy. We're going to clear this up. All right, so I got 2. All right, oops. Okay, so I got 2. All right, I got x. All right, I got y. 2. Square root, all right, with the 6 there, all right, I got y1 and z3, okay, and there's my answer, all right. Moving on, all right, to this next problem, okay. All right, so what I'm going to do here is I'm going to take the square root of 125 and I'm going to divide by the square root of 5, all right, and I'm going to find out, all right, but that's just going to be 5, okay? Actually, let me double check that. Let's do a square root of 125, all right, divided by the square root of 5. Oh, yep, it is 5, so that's nice. So that's 5, okay, on the outside. These would be, this minus this would be x to the 6th. I would take x6 and divide by 2, reason being it's a square root, that's 3. So what I'm going to end up with is 5x to the 3rd. There's actually going to be no radical answer there. Okay? All right? And that's all you have to do for that one. All right, this one I will type in is 4th root of 12 times 5 times, 5 times the 4th root of, okay, 27. All right? Got 21.2. Okay, so what I would do, right, this is going to be 5, the 4th root over here, okay, 12 times 27, okay, which is 324, all right. I'm also going to add these exponents, so it's going to be x7, okay. I'm going to move this up, I'm going to extend the page, all right. Okay, so I break this down. This would be 2, and it's 324 divided by 2. Okay, it's a pretty big number. All right, 162. All right, then it'll be 2 and 81. Okay, 3 and 27. And you can just check these in your calculator. I'm moving pretty quick. 3 and 9, 3 and 3. All right, you can cross off all these. Okay, since I'm looking for a group of 4. So here's my group of 4. Now, I'm going to take one of these 3s, and I'm also going to take one of the 5s. So that's going to be 15. All right. I have a little 4th root over here. All right, things left inside of 2 and 2, which would be 4. I would take 7. 7 divided by, this time the root is 4, so that's going to be 1 with a remainder. If I multiply back, it's 4, 3 more, so x1, x cubed. That's my answer, okay? All right, now I'm going to go back up to, all right, these on the other side here, okay? All right, now, these are, all right, it looks like they can be reduced, but here's the problem. When I type in 4, all right, that's 2 and 2. I'm looking for triples, so all of those are reduced, okay? And in fact, all the variables are reduced as well. Now, I can only combine the ones with the exact same parts underneath. So 6 minus 4 would be 2 cubed root of 4x squared. And this would just say 2 square root of 3x, okay? I cannot combine those because those do not, cube root as well. They do not have the same term underneath, okay? All right, moving on to question number 25, all right? You should also always check to make sure you're typing these in as well, okay? All right, including the additionals, right? So I would do 3 square root of 128, okay? All right, minus 4 square root of 108, all right? Minus 5 square root of 162. All right, so I get that. I get a negative answer. All right, well, let's see what I get here. All right, If I break down this will be 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Can't use those anymore. I'm looking for pairs. Okay, so what I would have over here, one of these, one of these, one of these, and that 3. So it's a lot of numbers multiplied. So 3 times 2 times 2 times 2. Okay, so that's going to be 24 with a root of 2 on the inside. Okay, so I'm going to put that, I don't have a ton of room here. I'm going to put that 24 root of 2. Okay, I'm going to break down this one. That's going to be 2 and 54, 2 and 27, 3 and 9, 3 and 3. Okay, once again, I'm looking for pairs. Here's a pair, here's a pair. All right, so I'm going to put a 2 over, I'm going to put a 3 over, and I'm going to put a negative 4 over. So 4 times 2 times 3. 4 times 2 times 3 is 24. All right, so minus 24, but inside is 3. Okay, because that's the left one. All right, okay, then I got 2 and 81. All right, 3 and 27, 3 and 9, 3 and 3. Okay, I can't use those anymore. Okay, so here's a pair, here's a pair. All right, and I'm also going to have this, so I have one of these, and I'm going to have that negative 5. So 5 times 3 times 3 gives me negative 45. All right, negative 45 with the 2 inside. Now that I've done, that's a lot of work. Okay, the two things that can combine are this and this. Okay, so that's going to be negative 21 square root of 2. All right, minus 24 square root of 3. Now at this point, I've done a ton of work. I hope my answer is correct. That was my original. I mean, that is a lot of work. All right. Minus 24 square root of 3. I hope that's right. And it is. Whew, that was a lot of work. And I'm glad I got that one right. All right. I want to go back and change that one. All right. This one, okay, what I'm going to do is I'm going to do boxes for this. Okay. 2 square root of 3, square root of 5, 3 square root of 6, negative 4. So this would be 6 square root of 18. Okay. This would be 3 square root of 30. This would be negative 8 square root of 3. And this would be negative 4 square root of 5. Okay? Now, this and this are prime, so I'm good there. If I check 30, 2 and 15, 3 and 5, there are no doubles there, so I cannot use that. So that's as good as I'm going to get. Now, I got to check 6 square root of 18. Okay? That's 2 and 9, 3 and 3. Okay? All right? This is the only pair there. All right? Okay? So I multiply that by 8. So that's going to be 18. Okay? Square root of 2. All right? Now, if I look, I cannot combine any of this. So as bad as this is what I'm going to have for my answer. 3 square root of 30. Okay? Minus 4 square root of 5. All right? That's going to be my actual answer. I can't combine any of those. Okay? This one, all right? You're actually only going to need a couple boxes here. Okay? I got square root of 2, 3, 4 square root of 10. So what I got is 3 square root of 2. Okay? This times this will be 4 square root of 20. Well, let's break down 4 square root of 20. Okay? That's going to be 2 and 10, 2 and 5. Okay? You can't use those anymore. All right? I would take this and this. This would give me 8 square root of 5. So my answer is 3 square root of 2 plus 8 square root of 5. I cannot combine those because they do not have the same number underneath. Okay? And this last one here. Now you can check all these for addition. I know I'm going through pretty quick, but you can check all these. Okay? All right? So let's break this one down. That's 2 and 8, 2 and 4, 2 and 2. Okay? There's a triple here. So I take one of those triples and that's 6. Will give me 12 cubed root of 2, okay? 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Can't use those. Get my triple again, okay? So I also got to take this into account and one of those. So that's negative 8, okay? Third root of 4, okay? And then I got this, all right? 2 and 27, all right? 3 and 9, 3 and 3. Okay, there's my triple. Can't use those. Okay, I got to include the 2, got to include the 3, so it's going to be 6, all right, cube root of 2. All right, now I'm going to look back and say, okay, what can I combine? well, I can combine this one and this one, so that gives me 18 cube root of 2 minus 8 cube root of 4. And if I wanted to check my original, which you can, okay, 6 cube root of 16 minus 4, actually that's fourth root there. Oh, whoops, I made a mistake, okay, hold on, that's the fourth root. Let me fix this real quick, all right, 2 and 16, 2 and 8, 2 and 4, 2 and 2. All right, I would look for fours, so this and this would give me negative 8 fourth root of 2. All right, I still can't combine that because those are different roots. Okay, so 4 times the fourth root, times the fourth root of 32 plus 2 cube root of 54. Okay, so I get that for an answer. Okay. Okay, so if I check that, that's 18 cube root of 2 minus 8 times the fourth root of, hold on, 2 minus 8 times the fourth root of 2. Okay, and that matches, as you can see. All right. Okay, I think that's it for that page. Okay, now on to the next page, only a couple left. All right, now, as you can see, I'm going to have a negative cube root, or negative square root. So I got to go back to the menu, shift, menu, and I want to go back in and change that to a plus bi milli. Okay, so that will help me. All right, because when I type in the square root of negative 75 divided by 2, okay, I get 6.1i. Now, here's what you should do in this. Okay, you get 75 over the square root of 2. Now what you have to do is multiply that square root of 150 over the square root of 4, which will turn into 2. All right, I break down 150. Okay, that's 2 and 75, 3 and 25, 5 and 5. There's my pair. Okay, so that would be 5 on the outside and 6 on the inside. And there's my answer. Okay, all right. Now I got to make sure I put an I there. All right. The reason I got to put an I there is that's what I got for my answer. So once again, if you wanted to check this, you absolutely could. Okay, and then divide it by 2, and you'll notice you got a match. Okay, square root of negative 180. Square root of negative 180. All right, I got an I, 13i, so I know my final answer is I. So once you know that, you can sort of move on, all right, and reduce it as if it's positive. Okay, 3 and 15, 3 and 5. Okay, I'm just dividing by prime numbers. All right, here's a pair, here's a pair. So what I got is 6, square root of 5. Do the same thing as if I was doing the other ones. 5 divided by 2 would be 2. My remainder, if I multiply, would be, that would be 4. One more, so it's x squared with x. Okay, and then y 6 divided by 2 would be 3. And remember, I have my answer of I, so I'm going to put an I right there. And once again, I need to check it. All right, 6, shift, I square root of 5. Okay, all right, let's check this one. All right, 3, parenthesis, negative 98 times square root of negative 6. All right, as you can see, my answer is negative, so don't automatically assume that you're going to have an I in there, okay? Don't automatically assume that, all right? So here's what ends up happening. I got 3 square root of, okay? I got 98 times 6, all right, 588, a very large number, all right, 588. Okay, let me use black. All right, so that's going to be 2 and, all right, 294. That's going to be a couple of them so I can see. 2 and 294, 2 and 147. 147 is not divisible by 2. Is it divisible by 3? Yeah, 3, all right, and 49. And 49 is going to be 7 and 7. We don't see that one that often, but that's okay. Once again, I'm looking for pairs here. here's a pair, here's a pair. I also got to count that thing right there. So multiply, multiply, multiply. That's 6, that's going to be 42. Okay, square root, that's what's left over. Now, if you remember my original, it had a negative, so I just throw that negative in front. All right, don't overthink yourself. All right, next problem, square root of negative 24 minus 2, square root of negative 54. All right, it's a negative with an I. Okay, so I'm going to go ahead and reduce this. This is 2 and 12, 2 and 6, 2 and 3. Okay, so this is my pair. All right, so I'm going to have 2 square root of 6. Okay, 54, 2 and 27. Okay, 3 and 9, 3 and 3. Okay, there's my pair there, but I also got to account for that. So that's going to be minus 6 square root of 6. All right, and if I subtract those, that's negative 4 square root of 6. And I got to put my I involved in the answer. Once again, if I type that in. All right, that's my final answer. All right, these, please don't outthink these computational problems. All right, these are very, very simple. All right, I to the 35. Okay, you just go shift this to the 35 power. All right, and then also do shift I to the 42nd power. Okay, negative I and negative 1. Okay, let's go back up to here. It's a very long review. Hold on, take that down. Oh, I think this is making it move over a little bit. Hold on. Okay. All right, so I'm going to clear this out. So all you got to do is type this in. What it's doing is it's adding the real parts and the imaginary parts. Come on. Okay, so that's the answer there. Okay, I'm going to do the multiplication. All you got to do is make sure you're typing it in there correctly. Okay. All right, so I'm just typing it in just like you see it. Okay, and the last one here. Okay, all right, this question, bottom 2 questions. Last 2 questions on this page, I think. Yep. All right, it says, write in A plus BI form. Okay, 2 ways you can do that. Square root of 36 is 6. You can write it as 6 or 6 plus 0i. Okay. Square root of negative 49 is 7i. So you could write this as 7i or 0 plus 7i. Those are 2 ways to write those answers. Okay, so we're going on to question 42. All right, write the simplest radical form. Okay, since these are the same base, this will be x to the 3/5. Okay, if I try to divide 3 by 5, all right, it's at 0 again. So since it's radical form, I gotta have my answer in a radical. So my root comes down here, x to the 3 stays all inside there. Okay, this would be negative 27 to the 1/3. Okay, which I got. Oops. See, now here's the thing. I gotta make sure I change it back to. I get that funny answer. All right, I gotta make sure I change this back to complex mode, A plus B, I want to do it back to real. So as you see, it's going to create 2 separate answers. I don't know why the Casio does that. It's one of the only drawbacks that I see. All right, to it. So as you can see, that answer is -3. Okay, all right, and if you multiply that, okay, that's going to end up being x to the -3. Okay, that's good enough as an answer there. Okay, all right. Moving on to question number 44. As you can see, I'll do 7 to the 1/2 just to double check to make sure it's not anything nice. Nope, it's not anything nice. Okay, so that's going to stay square root of 7. I can't break that down because that's already a prime number. All right, I am going to try to reduce 5 over 2 for x, which will be 2 remainder of 1, because that would be 4. Okay, so I would have x squared outside, x on the inside. This would be 3 divided by 2, which would be 1 with a remainder of 1. Okay, because 1 times 2 is 2. 1 more, so that's going to be y1 each direction. Okay, 45. Those are not the same. So things that make sense would be to get this to be 21. So I'm going to multiply this by 7. Multiply this by 3. So I got x7, 21, y6, 21. Now, if you divide those, the good rule of thumb is if this is smaller than this, they're going to stay in there. Right? So 7 divided by 21 and 6 divided by 21 both have the zeros. So the big thing is you put 21 as the root, 7 and 6. Okay? All right, let's go on to the last section. I think there's a section here and then some review. Okay, right with rational exponents. Okay, so that's going to be z7 divided by 3. The root always goes under here. Okay, I just have to check to make sure that that doesn't reduce. You can do that by hitting the fraction decimal button. Nope, doesn't do that. All right, going on to 48 because I see it right here. All right, this would be 5 to the 1/8. Okay, this is a 1, so that's x to the 1/8, 10/8, and z 4/8. Okay, I just got to double check, and I got to do that. Remember, put parentheses around the fraction and make sure that's nothing nice, and it's not. Okay, 1/8. Nope, 10/8. That's probably going to reduce 5 over 4. So I got 1/8, 1/8, 5/4. And you can guess that that last one's going to be a half. Okay, all right, so that's going to be z to the half. So make sure you reduce all your fractions. If you don't, you're going to be wrong. Okay,